Hello everybody, I am Jairaj from GTTC Gulbarga. Today I would like to share with you about designing a press tool. Press tool is a device which produces sheet metal component in mass quantity. More than 100 years back, press tool was into existence and so was its designing practice. But with the updated technology, press tool design has become a real challenge in the tooling competition. Today I would like to present a benchmark for designing a press tool. Something you must know before you design. Especially, this presentation is for the final year diploma in tool and die making students. So let's move ahead into this presentation. Designing involves various concepts of engineering drawing techniques along with the press tool knowledge. Design can be represented manually by drafting on a sheet or by designing using a design software like AutoCAD, SolidWorks, Unigraphic, etc. Here on the screen, you can see a press tool assembly in an orthographic projection and in an isometric projection along with a bill of material which you call it as a part list. It is responsibility of a designer to provide a complete drawing for manufacturing of press tool in a tool room or a workshop. Hence, a benchmark is required for a designer about what he or she should know before starting a design. Here are some of the points. One should have a good complete knowledge of manufacturing or machining aspects and other necessary design aspects such as geometrical tolerances. One should have a good knowledge about selection of the right material required for manufacturing a press tool. One should be flexible to design a press tool to suit the customer requirement. Sometimes a customer comes with a small lot requirement or a large lot requirement, and sometimes a customer comes with a mass continuous production. So in all these things, the design should be able to suit the customer's requirement. And finally, one should have a good knowledge about costing of the tool. Speaking about the selection of the material, of a right material, here I would like you to look at this chart on the screen. You can see all the parts has been placed on a description with the right material and the hardness required. You can see a shank with ST42 MS and then a top plate with an MS or a CI. Sometimes if a design demands a standard die set, then cast iron is required. And a guide bush of OHNS with hardenable material with 56 to 58 HRC, thrust plate of OHNS with 50-55 HRC, punch holder of ST42, punches of high carbon high chromium steel HCHCR of 5860. Now here in the punch it depends on the type of operations. The punch, if it is cutting operations, performing a cutting operations, then it can be the metal can be selected as HCHCR, and if the punch is for non-cutting operation, then OHNS metal can be taken. Then pilots with OHNS material of 50-55 HRC, then stripper plate of ST42, then die block. Once again here the operations type of operation performed matters a lot in selection of the material. For a cutting operation it is HCHCR with 60-62 HRC, and for non-cutting operation it is OHNS with 50-55 HRC. And then guide pillar of case hardening steel with 50-56 HRC. Then you have a various stoppers depending on the uh, type of designing a tool. It can be a stage stoppers or a final stop or might be a trigger stoppers. So all these stoppers are made up of material with OHNS of 50-55 chassis. And then you have an if the design demands an ejector or a shedder, then the material selection can be of OHNS of 50-55 chassis. And then finally it's the bottom plate, or you call it as in die shoe, and it can be of MS, and if it is from standard die set it can be of cast iron. And this all these parts can be supported with hardware of screws, dowels, springs of various compression springs, and then ball cage push. Now coming to the next slide, before you start designing, you must focus on the following requirement. The accuracy and the surface finish of the component produced by a press tool should confirm the component in the drawing and its specification given by a customer. The second point is working of a tool part should be adequately strong enough and durable enough in the operation and should be easily replaced when they are worn out or damaged. The third one is the tool should perform a specific production rate. That's what we call it as the component produced per rate with easy maintenance and safe to perform. Then next one is the tool should be designed with a standard items and the hardware and the standard die set so that the manufacturing time can be minimized. With the present competitions, it's very important to focus on the time management of manufacturing a tool. The lesser the time, the better the production or the business of tooling with the customer. And then finally, the scrap should be kept to the minimum, whether it is manufacturing or the material scrap or excess material. The right extra material has to be kept for all the plates, and then after the tool, even in the strip layout, the strip has to be in a very economic so that the minimum scrap can be produced. Now we are coming to the important part, content of the design. That is what we call it as a component analysis. Now I would like to emphasize that most of the time, the reason for an ineffective or a failed design can happens because of not understanding in depth the component drawing and details and the information given by the customers. Most of the time, without going much depth into the component analysis, the design starts and then the manufacturing starts, and at somewhere the the whole thing is been stuck up with a chain of mistakes that can occur in the later part of manufacturing or an inspection. So it's very important to study the component in detail before you design a press tool. Let's see what are the points to study in this screen here. The first one is the type of the material and the sheet thickness. It's very important to understand because everything depends on the material of the component and the sheet thickness. If you want to calculate the force, cutting force, clearance, all the press tool calculations are mainly focused on this particular platform, that is material of the component and the sheet thickness. Now the second point is the critical dimensions. So sometimes the component has some critical dimensions in it. They are very important because a component may go for an in assembly or in online assembly, inline assembly with another component. So the dimensions are very important and critical. So it's very important to understand whether a press tool may be able to fulfill these critical dimensions or may be able to satisfy these particular dimensions, critical dimensions. If they are okay, then it has to be designed, or it has to be subjected for next other tooling operations. It can be subjected to a jig, or after uh, or it can be adopted in a press tool design after the particular operation such as bending operation is completed. It can do for a piercing in a single stage tool. And then next comes is a general dimension. So the most of the components in a press tool, almost like 60% of the dimensions are in general. So that is definitely a press tool is capable of achieving those dimensions, and then it can be produced. And then next comes is we have to understand how much or number of press working operations that are involved. See, now you can see a particular component here. You can see there is a bending operation, there is a piercing operations. It can be a piercing or a notching here, and then on one more bending and two piercing operations are there. So understanding the number of operations involved in a particular component plays a very important role on how the structure or how a press tool is adopted or developed there. And then the next one is the quantity requirement of by a customer. So it is very important. For a smaller quantity, it is a crime to design a very complicated tool. So generally for small quantity, accordingly, most of the time the customer may require a small quantity. Then it is advisable to design a single stage tool. It can be a separate tool for a blanking or piercing and then bending. So that is most advisable for designing. So a quantity depends. In case of mass quantity, then it is advised to go for a progressive type of press tool. And then the final one is the type of the press tool required to produce the component. So whether you require a compound tool, or you require a single stage blanking or bending or a draw tool, or you require a progressive type of tool. It might be a progressive cutting tool, it might be a progressive forming or bending tool, and then sometimes it might be a combination tool. So it all depends upon the shape and structure of the component. So that's why the component study is very, very important. One has to study the component in detail, and also the instructions provided by the customer regarding the requirement of the component. Here, as I was talking about various press tool operations, it is very important that we should know it. This is already been represented in the theoretical part of the press tool, but I am just focusing you or recapping you to understand the operations. Unless you don't know the operations of a press tool, it is very difficult to imagine here on the component what a type of press tool is required. So here are the press tool operations. Basically, the operations are classified into three major groups, that is cutting operations, non-cutting operations, and hybrid operations. And in cutting operations, you find various operations like trimming, shaving, blanking, piercing, cut off, part off, and notching, etc. And then in the non-cutting operations, you find bending, coining, forming, drawing, embossing, curling. And in the hybrid operations are the combination of both cutting as well as non-cutting operations. You can see some of the components samples I have given here is been displaying here with this particular thing is an hybrid operation. You can find it as a non-cutting operations like coining operations, drawing operations, and then embossing operations. You can find here the trimming operations, then notching operations, and then piercing, blanking operations. So here in hybrid operations, you find lancing, flanging operations, and then lowering operations. So the press tool, understanding the press tool operations are very, very important. As we go to some of the other operations in depth with the non-cutting operations, which we call it as an advanced press tool operations. And these are the operations in bending you can find as a wiping tool, a V bending operation, air bending, bottoming of dies, U bending, Z bending, and then in drawing you can see shallow drawing, a deep drawing, some flange drawing. This drawing is very difficult part because we have to maintain the flange as well as then draw with a cylindrical diet. And then non-circular draws are very important because at the corner side it is very important to the metal flow is been restricted because of the smaller area, whereas in the straight area the metal flow is very fast. So we have to balance the speed of the metal flow in these two areas. So and then we have a reverse drawing tool also. And then in forming we find embossing, coining, curling, bulging, swaging, necking, flanging, and then extruding. These are some of the non-cutting operations for your information in depth. Now, after the operations, it is very important to understand the construction of the press tool as it has been highlighted in the study of the component. What type of press tool can be designed for a particular component? So here we see in the constructions majorly you can see a single stage construction and progressive stage construction and then a compound stage constructions. So based on that, if the quantity is very small or very less, then it is generally advisable to go for single stage. So in a single stage operations, the each operations are separated into a separate tool. You can find it as a blanking tool can be done in one particular tool, a small tool, then bending tool, or a piercing tool, or a different draw tool. So accordingly, so this type, and it depends on the requirement of a customers. Then the progressive tool here, it has many stations. So you cannot restrict. It depends on the type of the component and what operation it is going to perform. So basically more than one station, then a tool becomes a progressive stage, and then a compound stage. So this particular construction is very critical in designing because there are the parts becomes very critical. The concept of the design, we can say a conventional in design. As per the conventional design, the generally the punch will be on the moving half and the die will be on the fixed half, and then here the die goes to the moving half and then punch comes down. So most of the time here we see that a compound stage construction or a design is very critical, and then comparatively the cost of the single stage or the cost of the compound tool is much higher compared to the single stage or a progressive stage. And then here we come into the next slide. It is the steps involved. What are the steps you have to consider or you have to think before you start designing? Okay, you should plan before the start of the these things. All you should plan before you start with the actual designing. The first one is the determining the force of the or you can call it as a press tonnage required for the operation. And the second one is the selection of the press for the requisite force. What are the required force? It is very important that you are supposed to have the press selection of what type of press, because based on the component studies it is always as a designer you have right to question the customer to what type of press a particular this tool they are going to load it. So the information of the press has to be got from the customer, or if the customer does not have, then it is the duty of a designer to give every information about the requirement of the press to the customer. And then we see determination of the determining the shut height of the tool. The shut height of the tool is very important so that you can know what is the so that you can come to know whether it can be loaded properly into the press or not. Then calculation of the die thickness, and then further, once the die thickness is finalized, and then based on these references, all the other parts of the plates of the plate thickness can be finalized, and then designing of stoppers and registry elements, and then selection of the hardwares such as Allen screws or CSK screws, dowel springs, whatever is required. It has to be finalized what actually is necessary, because once the type of tool is been finalized, then all these things comes into the picture. And then selecting of the right die set, whether you want a rear pillar die set or a center pillar, diagonal pillar, four pillar, or sometimes multi-pillar die sets can also be. In case of 16 stage progressive or more than 16-20 stage progressive, then there will be more than four pillars uh, in a particular press tool. So it can be of a multi-pillar die sets. And then if the accuracy is very high, then it is always advisable to go with a ball cage rather than a plain pillar and bush as a guide post. And then deciding the punch length and the mounting, so how you are going to mount the punches. So all these things has to be taken into consideration before you start with the actual designing. Now we are coming into the uh, next slide, that is about the procedures now, or a pattern of designing a press tool. So generally, with all this information, now you have it. Now you start designing. The first thing is you are going to design a strip layout, and then it has to come to the die layout. With a strip layout, you come with a die layout, then with an assembly. In an assembly, there are various orthographic assemblies like plan views, and then elevations, and then side views. If required, you may have to go with the side view assembly also. And then with the different part details, it can be punch part. Sometimes it require all the parts drawings have to be generated. So the part details are important, and then the bill of material, or which you call it as a part list. So in a right pattern, design should be presented with a strip layout, die layout, assembly, part details, and bill of material. And just I want to tell you that in the days to come, I'm going to come with a different videos about individual topics about strip layout, how to develop an economical strip layout, and then how to design an complete, effective, or a detailed die layout, and then assemblies, then parts, and then the bill of material. All these videos in the days to come I'll be releasing for you to learn. Okay, now I'm going to show you about a live study about working of a press tool. Here, this is a video, and before this, I just want to highlight some of the things here. First thing is, it is a 7-stage progressive tool. It is a progressive forming and bending tool. You see various operations, piercing operations going on, and then you see bending operations, then embossing operations, and forming operations in this. And in one thing which you want to, we observe here in this tool is that the movement of the strip is clearly visible. Sometimes in a design you should make an arrangement to see that the movement of the strip is clearly visible to an operator. Here in this case study, because of many complicated operations in this particular tool, it is very important that the visibility of the strip movement is very important for an operator. And that's how you can see the pins are here, and they have been placed here, and then you can see a groove in this, and then this groove will act as a path for this particular strip to move in a right line. Or you can call it as a die railing, rails, or a strip guide. We can call it as a strip guide. And apart from this, we have a floating stripper on the moving half to hold the strip before the operations are going on. And one more particular thing is, because of all the various complex operations are going on, the alignment of the press tool is very important. So you see ball cages are being placed here in all the four pillars. So these ball cages will maintain a perfect alignment between the two moving half, the top half and the bottom. So you just watch the video now. Well, that was the video. As we conclude this presentation, I thank you all for listening patiently to my presentation, and I hope you might have got some idea what should be the benchmark of before you start designing a press tool. In my next videos shortly, I'm going to come up with a strip layout, die layout, assemblies and various other aspects for you to learn. Thank you very much.